Hi guys, in this video, we will just solve more problems about derivatives, and we will just solve those functions that I think are complicated enough to solve, and therefore we need to apply all the rules that we just have learned so far from this tutorial series, such as chain rule, product rule, quotient rule. And if you haven't watched so far, guys, those videos, I recommend you to watch them first so that you can solve at first by yourself the following functions that we will solve, and then at the later part of the video you can check whether your answer is correct. So particularly these are the functions that we will try to solve, um, and obviously we must apply all the rules that we have studied so far, such as chain rule, quotient rule, product rule, etc. So let's start. So let's have the first example. So we have y is equal to 3x squared plus 2 quantity squared times x squared minus 5x quantity cubed. So obviously it is an example of the product of two different functions, and each function is a composite one because they involve a quantity raised to a particular power, in this case 2 and 3. So we will use both product rule and chain rule to attack this problem. So let's start. So y prime will be, so for the product rule, the formula states that we'll just have to copy the first function. So let's say 3x squared plus 2 quantity squared, then multiply it by the derivative of the second function, which is in this case, let's say x squared minus 5x quantity cubed. So since it is a composite, we will apply chain rule. So applying chain rule to find the derivative of the second function, we have 3 times, copy the inside, x squared minus 5x, then applying power formula, 3 minus 1, so it will have an exponent of 2, and then we'll have to multiply it by the product of the inside, by the derivative of the inside function. So it is equal to 2x minus 5. So we're done for the first term of the product rule. Then let's proceed to the second part. So the second part, according to the product rule, we'll now have just to copy the second function. So x squared minus 5x quantity cube, then multiply it by the derivative of the first function. And again, the first function is a composite one, so we will apply chain rule. So differentiating it, we have 2 times, copy the inside, 3x squared plus 2, then subtract 1 from this exponent of 2, so we still have 1, then multiply it by the derivative of the inside, which is 6x. Okay, so we're done with the differentiation. The next step will be the simplification. So simplify it. So let's find first their common factor. So for the constant, we have 3. For 3x squared plus 2, we have yes, we have 3x squared plus 2 raised to 1 only, since we're looking for the least common factor. Then for the x squared minus 5x, we'll have raised to 2, since it is the least one. Then for the first part, factoring out this common factor, we will still have one quantity of 3x squared plus 2 for x squared minus 5x, so it's already factored out. Then 2x minus 5 plus, so for the constant, since we have 2 and 6, it's equal to 12, and we factor out the 3, so we still have 4. So we have 4x, and then for the x squared minus 5x, we still have one quantity since it is cubed and we factor out squared, so x squared minus 5x. For 3x squared plus 2, we'll already factor it out, so it will have no longer it. So we can simplify it further, so just copy 3 times 3x squared plus 2 quantity times quantity x squared minus 5x squared. Then let's apply the FOIL method to find the product of these two binomials. So we have 3x squared times 2x is 6x cubed. Then 3x squared times negative 5, negative 15x squared. 2 times 2x is positive 4x. 2 times negative 5 is negative 10. Then just distribute this 4x to each of the terms. So plus 4x cubed minus 20x squared. So simplifying further, 3 times quantity 3x squared plus 2, then quantity x squared minus 5x squared. Then simplifying let's combine the common terms here. So for the x cubed, we have 6 and 4, so 10x cubed. For x squared, we have negative 15x squared and negative 20, so we have negative 35x squared. For x, we only have 4x, and for the constant, we have negative 10. Okay, so I think we already got the final answer, and this will be the final answer. So let's proceed to the second example, which is this function. So y is equal to 2x plus 1 over 3x minus 1 raised to the 4. So obviously, it is a composite function since we have a quantity raised to a power, which is 4, and then we have the inside function, which is a quotient of two different functions. So we will have both chain rule and quotient rule. So let's have it. Y prime will be, applying first chain rule, so we have 4 times copy whatever is the inside, which is 2x plus 1 over 3x minus 1 quantity raised to 4 minus 1 will be 3, and then let's proceed to the derivative of the inside, which is a quotient. So we will use the quotient rule. So it states that for the numerator, copy first the denominator, so 3x minus 1 times, multiply it by the derivative of the numerator. So the derivative of the numerator will be 2, then minus, copy now the numerator, which is 2x plus 1, then multiply it by the derivative of the denominator, and its derivative is 3. Then for the denominator, we just have to square 3x minus 1. Okay, so I think we're done with the differentiation. The next step will just be simplification. So 4 times 2x plus 1 over 3x minus 1 quantity raised to cube. Let's just simplify the numerator. So distributing to 6x minus 2 minus 6x minus 3, then 3x minus 1 quantity squared. So we have y prime will be, so I want to distribute now the exponent 3 to numerator and denominator. So we have 2x plus 1 cube over 3x minus 1 cube, and then we have cancel negative 6, and we have negative 5 over 3x minus 1 quantity squared. Alright, we can now multiply the constant. 4 times negative 5, we have negative 20, then 2x plus 1 quantity cube. For the denominator, since they are the same base, 3x minus 1, and they have exponent of 3 and 2, we'll just add them. So we have 3x minus 1, 3 plus 2 will be 5. So I think we already got the final answer. Okay, let's now proceed to the last example, which I think is the most complicated one. Okay, alright, we have y is equal to square root of x tangent of square root of x over x plus 1. So I think I want to rewrite it first by making the radical equivalent to fractional power. So we have x raised to 1/2 times tan x over x plus 1 quantity raised to 1/2. So how will we attack this? So notice that we have a product of two functions, which is x raised to 1/2 and this tangent of this quantity. And when we differentiate this tan, which is a chain rule, we will encounter a quotient of these two different functions. So in this example, we will use all the three rules: the quotient rule, product rule, and the chain rule. So let's start. So y prime will be, let's start with the product rule since it involves the product of these two different functions. So again, according to product rule, let's copy the first function, which is x raised to 1/2, and then differentiate the second, which is tan of this quantity. So obviously it is a composite function, so we will use chain rule. So the outer function will be this tangent, so the derivative will be secant squared, copying whatever is the inside, which is x over x plus 1 quantity raised to 1/2, and then multiply it by the derivative of the inside function, which is this quantity raised to 1/2. And using power formula, we can find the derivative to be 1/2 times x over x plus 1 raised to, so we'll subtract 1 from the exponent, so 1/2 minus 1 will have negative 1/2. And then for the last part, the innermost function will be this quotient of these two different functions, so we will apply quotient rule in finding the derivative. So multiply it by, so applying again quotient rule, copy first the denominator x plus 1, multiply by the derivative of the numerator, which is x, its derivative is simply 1, minus, copy now the numerator, multiply by the derivative of the denominator, which is also 1, and then for the numerator we'll have to square x plus 1. Okay, so we're done with the first part of this product rule, so we'll proceed to the next part. So for the second part, we will now just have to copy the second function, which is tangent of x over x plus 1 quantity raised to 1/2, and then multiply it now by the derivative of the first function, which is x raised to 1/2. Its derivative is 1/2 times x raised to negative 1/2. Alright, we're done with the differentiation. We can now proceed to the simplification. Okay, let's do this. Y prime will be, so I want to put the constant 1/2 in front, and then copy this x raised to 1/2, and then I want to distribute this negative 1/2 to the numerator and the denominator. So I'll have x raised to negative 1/2 over x plus 1 quantity raised to negative 1/2, and then for this part I'll just have to simplify, so we'll have x plus 1 minus x, so we'll cancel out x and we'll have 1 on the numerator, so we will have 1 over x plus 1 quantity squared, and then this second squared, copy it, second squared of x over x plus 1 quantity raised to 1/2. Then for the second part, we have to just copy 1/2 and x raised to negative 1/2 tangent of x over x plus 1 quantity raised to 1/2. Okay, so we can now cancel, I think, this x raised to 1/2 and x raised to negative 1/2, since if you add up their exponent it will become 0 and x raised to 0 will be equal to 1. Also, we can add the exponent of this 2x plus 1 since they have the same base, so we'll have negative 1/2 plus 2 will have 1.5 or 3/2. So let's write it down first. So 1/2 over 1 x plus 1 3/2, right? Then second squared of x over x plus 1 raised to 1/2 plus 1/2, and I want to write the x raised to negative 1/2. I will write it as 1 over x raised to 1/2 since it is a negative exponent. So cotangent of x over x plus 1 quantity raised to 1/2. Okay, so I think we can factor out 1/2, so 1/2 times, so I think we can now rewrite all the fractional exponent into radical form again. So let's copy it over square root of x plus 1, right, plus 1 or tangent square root of x over x plus 1 over square root of x. I think that is the final answer already. A very complicated answer. So, thank you for watching, guys, and I hope you learned something from this tutorial. And see you again for next videos. Thank you, guys.